So first, let's try to find I think it's a cosine of 15 degrees. Yeah, cosine 15 degrees. 15 degrees is pi over 12. Give an exact value. So you can't just put it in your calculator and write down what you get, because that's an estimate, because you always have to round it off. So solution 15 degrees is 45 degrees minus 30 degrees, which in radians is pi over 4 minus pi over 6. So I want to find cosine of 15 degrees is going to be cosine of pi over 4 minus pi over 6. Now, I did this in radians because I like to keep my calculator as much as possible in radians. But of course, you could do this in degrees as well, and it'll work out the same as long as you have your mode on your calculator set to degrees if you're doing it in degrees, or radians if you're doing it in radians. Okay, hopefully you've got that figured out by now. So this is going to be cosine pi over 4 times cosine pi over 6 plus sine pi over 4 times sine pi over 6. That's the formula. Well, with the numbers plugged in. So I need to figure out what cosine of pi over 4 is, and cosine of pi over 6, and sine of pi over 4, and sine of pi over 6 exactly. So I'm doing the pi over 4 first. So I draw a right triangle with a pi over 4 as one of the angles, and this is an isosceles right triangle, right? So the lengths of the sides are 1, 1, and square root of 2. And then once I get that, I can figure out what the cosine of it is. It's in the first quadrant, pi over 4 is, so that makes it easy. So, and then I drew the same one for pi over 6. The side opposite the pi over 6 this is just the template size, right? Both of these are. So the side opposite is 1, the hypotenuse is 2, and the adjacent side is square root of 3. Okay, and then I want to find cosine of the first one, sine of the first one, cosine of the second one, sine of the second one, etc. So I did cosine of pi over 4 is this actually the same as sine of pi over 4 because the two legs are the same. So cosine is adjacent over hypotenuse, which is 1 over square root of 2. Sine is opposite over hypotenuse, right? Opposite over hypotenuse, which is also 1 over square root of 2. So these two are both the same for this angle, because these two angles are the same. Okay, so for pi over 6, they're going to be different, though. So for pi over 6, cosine is adjacent over hypotenuse, so that's adjacent over hypotenuse, square root of 3 over 2. And sine is going to be opposite over hypotenuse, which is 1/2. So you have to know how to figure those out. Hopefully you do by now. Then you just take those numbers and you plug them in for these values here. And you get 1 over square root of 2 times square root of 3 over square root of 2, 1 over square root of 2 times square root of 3 over 2 plus 1 over square root of 2 times 1/2. And notice the denominators match, which is kind of nice. So 1 plus square root of 3 over 2 root 2. Now you could rationalize the denominator if you want, but it actually makes it somewhat more complicated, so I just left it this way. 1 plus square root of 3 over 2 square root of 2. So that's the exact value of cosine of 15 degrees.